Example 4, a quadratic model. A ball is dropped from the upper observation deck of the CN tower 450 meters above the ground, and its height h above the ground is recorded at 1 second intervals in Table 2. We want to find a model to fit the data and then use the model to predict at the time at which the ball hits the ground. So the first thing we want to do is we can put this data into either the TI-83 or 84 or in Desmos. Let's start out putting it into the TI-83-84 calculator. So here's my calculator. Okay, and what I want to do is, the first thing I want to do is I want to edit these numbers into two columns. You have time in seconds and height in meters. So if we go to Stat and then select Edit, then we can enter the numbers into each column, which I've already done. So for L1, you're going to enter 0 all the way to 9. And then for L2, you're going to enter the height, which is in meters. Now, the next step that we want to do is once we have this data, we can look and at least see what the graph looks like. So let's select Zoom. And then we're going to go all the way to Zoom Stat. And then we can see what this graph looks like. So it forms sort of a quadratic function. Okay? And so this is what our graph looks like. And what we want to do is we want to figure out, okay, what is this model? So rather than trying to figure this out, we can use a function on our calculator to find out what those values are going to be. So let's go ahead and hit Stat, and then we're going to go to Calculate. And since we know that it's a quadratic function by looking at the graph, we're going to go down to number 5. Oops. Stat. Go down to number 5. And then select Enter. And so now we have our quadratic regression. So what we know is that our function looks like the following. We know that we have y is equal to ax squared plus bx plus c. And so now we need to write down what is a, what is b, and then what is c in our calculator. So let me go ahead and copy that information. So by looking at this, we know that a represents negative 4.90. We know that b is 0.96 and c is 449.36. So let's go ahead and then plug that in. So this is what our model is going to look like. Y, which is equal to negative 4.90x squared plus 0.96x plus 449.36. Okay, now we do need to change our variables because the y is the height, so we're going to call that h. And that's going to equal negative 4.90. Instead of x, we're using the time t. So that's t squared plus 0.96t plus 449.36. Okay, now before we move on to part 2, let's see how we would do this in Desmos. So in Desmos, I'm going to go ahead and pull that up. Okay, and so what I've done is I've put the data into the table. In order to get to the table, you need to go to hit plus and then select table, and then you're going to enter in your information. And then what we're going to do is we're going to get another here. What we want to do is we want to find out, okay, what is the information that we need to find A, B, and C. So what we're going to do is we're going to select Y and then 1. And then we're going to use this symbol. And then we're going to type in A and then X1. And we need to square that because it's got to be a quadratic, and then it's going to be plus b, and then again x1, and then it's going to be plus c. So now, if you take a look at this information, this is what the parabola is, and it's going directly through those points. So if I go ahead and copy this information into my page, then you will see that it gives us the same information for A. So in Desmos and in the TI-83, so there is A, and there's A as well, and then B is 0.96, and there's 0.96, and then 449.36, and there's your values. So again, you can either use the TI-83 or 84 or Desmos to get the following. Okay, so now we can look at the graph. So here's our graph. So here is the scatter plot for the falling ball, and then now that we figured out what that equation looks like. So now in part 2, what we want to do is we want to use the model to predict the time at which the ball hits the ground. So when it hits the ground, that means the height is going to equal 0. So we need to figure out what does t equal, because we're looking for the time. We're trying to find the time at which the ball hits the ground. So if we set our equation 4.90 t squared plus 0.96 t plus 449.36. And so what we want to do is we're going to set that equal to 0 because that's what h is equal to. So in order for us to figure this out, we're going to have to use the quadratic formula. So t is going to equal the value of negative b, which is negative 0.96, plus or minus the square root of the value of b squared minus 4 times a times c divided by 2a. So there are two roots to this. We know that one of them is negative and the other one is positive. So it's going to be approximately t is approximately 9.67 seconds from when it hits the ground. Now there's a quick way of doing that rather than doing the quadratic formula. Let's take a look at the graph here on Desmos. Okay, so if the graph starts here at the top and it's going to hit the ground at 0, well then what is that point? Well, there is your point, 9.6740. The other root where it crosses the x-axis is negative 9.477. We don't measure time in a negative value. So therefore, here is your result. And that's how we get the result to be t is approximately 9.67 seconds, either by using the quadratic formula to find the positive root, or you can look at the graph and determine the result from there.